Hi guys, and today's video I'd like to talk about the output tube protection circuit in Peavey Classic microhead 20-watt amplifier and the bias signaling circuit. The bias is signaled by T1 and T2 diodes, green, red diodes. Okay, let's take a look at the schematic diagram on this amplifier. The output tubes are illustrated as V5 and V4. There are two poly switches connected to the cathodes of each tube. They're meant to protect the tube or the output transformer in case the tube goes short circuit, which is quite uncommon for all the other amplifiers, except for this amplifier. It's quite good protection here. As you can see, each poly switch is bypassed by 100k resistor. If you can let's take a closer look at this. There's K5 and F5 points to each side of the poly switch. K obviously stands for the cathode. I'm not sure if F point means in this case, okay? And those 2 points are crucial because they correspond to the bias signaling circuit. I'll just show here. Scroll it up a bit, okay? Let me see, where's that? Okay, here it is. There are 2 bias signaling circuits for each valve or tube, whatever. This is actually achieved by the operational amplifier LM358. One half of this amp is used for T1, the other half of this chip is used for T2, and you can see those points I mentioned before, K5, F5 for this valve, and K4, F4 for the bottom one. What happens then is, as you can see, there's a dual diode, dual LED, red and green, or 2 separate diodes connected, opposite direction. Obviously there's I just throw it up slightly. That circuit is supplied by 15 volts plus, which comes from the power supply. Okay, and then let me just scroll it slightly higher. Okay, here it is, 15 volts supply. And the crucial thing is that Q14, the transistor Q14, okay, it opens and closes. Normally in standby condition, there's no voltage in K5 or F5. Q14 stays closed, and because of that, there's no access to ground like Q14, and the red diodes conducts current only, as you can see, because the current in any LED or in diode, a forward junction, it comes from the anode to cathode, so positive goes on the anode and the negative on the cathode, and then this way the LED or any diode starts conducting. So if there's no access to ground, if this transistor is closed, the plus is here, and the red light conducts only. The red light, the red LED is on, okay? As the voltage increases and the chip starts conducting, that transistor opens and the green LED starts conducting, and it switches on rather than a red. So the green starts conducting, and there's a run mode position, so when you switch the amplifier on. Okay, now I was going to say, when any of the valve is mismatched around their bias, there's a different potential between both. One of the transistors is not fully open. In this way, the red light, the red LEDs is still on. The other could be working fine, which is signaled by the green light, so you have the mismatch of the valves or something. And this circuit. Another fault scenario is say for example there is a bad or shorted tube. Let's say this fault scenario, for example, the top valve V5 is shorted or badly damaged. That will obviously cause any amplifier, any other amplifier, that will cause the output transformer shorted windings, or it would result in killing the output transformer in some stage. There's a shorted tube would cause that, but we have a poly switch here on the, and it's marked 0.117A, so 170 milliamps. So in the faulted tube scenario, the current will increase over this limit, and that switch would open. It's like a fuse, you know. So what it means, if we have 350 volts on the pin 7, which is the plate, if that fuse opens, the same voltage is here, because it's the cathode is not linked to the ground, so the K5 goes high, goes full voltage here, okay. Obviously it's bypass 100k resistor here, but it's very high resistance, and the very high voltage will probably be here, because there's no access to ground. That fuse opens, and so K5 goes high voltage. So what happens, that in turn triggers this circuit, as I mentioned before, triggers protection circuit. This is K4, because it's okay, K5 here, so this is this top valve. There's a high voltage here as a result of the poly switch being open. It's dropped by 470k resistor, and that opens the Q13, okay? The Q14 starts conducting. That pin is automatically shorted with ground, GND. There's no voltage on Q14, and that transistor closes now, okay? If this transistor closes, it's like the same situation as in standby condition. So the red light starts conducting, the red LED lights up just to indicate the problem, you know, because there's a short circuit. Another thing worth mentioning, noteworthy in this amplifier, is that the supply circuit, which is slightly different from common circuits and valve amplifiers. The standby circuit. See, the plate is 396 volts in standby, and on mode, and run mode, is 363, which is lower because, you know, all the valves start conducting and they consume current, so the supply drops slightly in this case. But here you can see with the standby switch, the full plate voltage still goes to the anodes, the plate and the valve. So it's very dangerous. You might forget, you might think that on standby circuit there's no voltage. It's quite safe. There's no voltage going to the anodes of the tube, so it's basically safe to touch it. But it's not really very high voltage, you know, arrives at the anodes and the tube and the plates. Nearly 400 volts DC. What happens when you close that standby switch? The screen voltage, you know, is applied, you know, 360, 390, 360 volts to the screen. That's why the valve starts conducting. If there's no voltage in the screen, obviously the valve, even if it gets full plate voltage, it doesn't work. It's not conducting because there's no voltage going to the screen of each output valve. Okay. Well, let me know if you have any other questions about those circuits. The other thing is that don't forget to have to read the standby. I mean not standby. The bias testing points are. There you go. Let's have a look at the output stage again. I would normally measure bias in F5 point or something, you know, F4 points. You can use a, you know, voltmeter set up on DC millivolts to read the bias. I wouldn't really rely on those T-tube LEDs indicators here. I wouldn't rely on them. Obviously, as you turn up the bias knob, the bias spot, they'll probably go up from red to green, okay, to indicate the amplifier's is going to sort of, you know, proper adjustment of bias. But I wouldn't rely on this. I would just probably stick my meter on F5 or F4, as I explained in the previous video. I would turn the the bias knob up until, you know, until they go green. But obviously I would measure the bias, you know, here on the F5 and F4. I'll compare the voltages. If they are the same, roughly close to each other, it'll probably also mean that the valves are perfectly matched. Okay? Let me know if you have any questions about this circuit. Thanks very much for watching.